Hi, this is Steve Barton for Solid Rock Machine Shop Incorporated. Today we want to talk about grinding some bench stones. I watched a video by Robin Renzetti not too long ago. He's got an excellent video. We'll put a link to it in the comment section. I would encourage everybody to watch it because I'm not going to go into all the detail that he has done on this, but it was an excellent video and I was very impressed by it. But he will take a regular bench stone like this. It's a 2" by 6" by 1". It has a fine Indian stone on top. This is a coarser. I'm not sure what the makeup of this stone is, but he would put these on the surface grinder and he would take a diamond wheel and he would grind the surfaces, get them nice and flat. And by doing so, what he's doing, he's taking the peaks of all the individual grit on there and he's cutting them flat so they're on the same surface. Before you do that, you can take this block and you can put it on a piece of steel and you can bear down on it and you can actually start removing some steel with the fine side, less than as if you use the coarse side. But by grinding and getting all those peaks so that they're on the same plane, that they're all flat, at this point when you bear down on your part, you're not going to remove any material, or I should say, you're not going to change the size or the shape of your material. What you're doing is you're removing some microscopic burrs that will happen to protrude up from the part and that will fit in the little individual valleys if you could take a real high magnification of this block and see. And so it works real nice. And one of the things that I wanted to use a block like this primarily for is when I'm surface grinding. A lot of times you get some little defects on your magnet, little burrs that stick up. And I thought this would be the perfect stone to use on your magnet rather than having the stone before the diamond wheel. When you start putting on there, if you put a little pressure on, you always remove material. Here we just want to remove the high spots that you may create in the process of grinding. So he had an excellent video. I encourage you all to watch it. It's very good. One of the issues that you have when you're grinding a stone like this is non-magnetic. It will not grip on the magnet. So you would block both ends and you'd have a way to keep that where it will hold down. For Robin Renzetti, in his video, he's got these little spring clips that he made that actually work pretty nice, and he's got a lot of hold down force with that. I don't have any spring steel available, but what I thought, I just take some door hinge, regular door hinge, so that I got the movable side here. I have this shape, so this is at a little angle so that it would sit pretty flat with that. I have another angle cut this way so that when I set this up, well, let's just move to the surface grinder where I got a stone set up. When I set this up on the surface grinder and I have it blocked in, I can get it up there at the angle I want, get her kind of snug, turn the magnet on, and you can see I'm raised up a little bit here, but I still have a lot of magnetism pulling. I'm on this hinge, so as it pulls down and it's pushing against the block, against the stops. And Robin, he was showing how you take a little bit of a brass hammer, tap them in a little bit to get them seated. And you can see it's working pretty good. Now you would set your blocks behind here so it can't scoot that way, and this will be holding the block down. And now you can be set where you can run a diamond wheel over the surfaces. One of the problems I'm going to have with this hinge section, I have a 6" magnet. And by having a 6" magnet, I have about 4 inches right here. And I have a 2" block, so you can see a lot of the meat on this clamp is hanging over the table. The only thing that's gripping is this section right down here. I'd like it to be a little bit stronger, so we're going to make a new plate for this, and we're going to make it wider so that it comes out across a few more poles, and it comes up there so we can have 2 sections. We're going to increase it 1.5 inches on each side, 2 sections over here that will grip the entire length just about. and I think it will make it a lot stronger. So if this would happen to move and go down, you would lose your gripping power. So I'll remove this right now. And we'll go over to the other side of the shop here. Right here we have a Milwaukee 8-inch metal cutting saw. We use a blade with carbide teeth on it. They actually sell special blades for that that's designed for the steel with probably a better grade carbide. But I found out that if I just use even some of your regular wood cutting blades, they work pretty fine. I usually look and find them on sale. Some of the cheaper ones, I'll buy them. I use this saw for cutting plates like this. It's an extremely fast cut, works really nice, and so I already have this scribed out. And then this is the part that we're going to cut out in order to make that bottom plate. And I'm going to turn the saw on in a minute, and we're going to mute the sound because the saw is quite loud, but you'll be able to see it actually in action cutting. As you can see, it cuts really fast, cuts really nice, and this has proved to be a valuable tool for cutting stuff out of plate steel like that. We'll move over to the mill and we'll square the ends of this up, and we'll cut a little C-section out, put the tap toes, we'll surface grind that, get it nice and flat, and then we'll put that together and we'll have a new clamping system, and we'll show you some more of this in just a moment. As far as the machining process, there's another little thing that we did to our curtain vise that we altered it, so it's going to work nice for a thin plate like that. And we're ready to mill these edges, square them up, make them nice and smooth. Anybody who has any experience with milling will know that a setup like this with a thin plate, running a cutter across the top, this plate is going to flex, it's going to make a lot of noise, you're going to get harmonics going in there, and that's not going to be good for your insert, especially if you're using carbide. It's not going to last near as long, it's going to be very hard on it. There's a few tricks that you can use that help minimize that. You can take and grab a couple blocks off the scrap steel rack that are a little bit thicker, and you can just drop these in. And now when you come up there, you get some holding power up here. You put some clamps on here. Now we'll be able to take a cut across here without getting all the vibrations in there. Let's turn the three-phase converter on. And you see the finish looks pretty nice on there. If it had, without those blocks, the finish you would have been able to see movement in the plate. It would have showed up in the finish. You would have seen that. It looks really good. The method works really, really well. So we'll get this side filed off. have this plate scribed out right now for what I want to cut out. I want to remove this part of this material. I was on the mill. I had a center cutting in mill, 1/2 inch already set up, so I just set this in the mill, eyeballed it where I needed, and just plunged right through it, cut like butter, and then I just elongated a few, maybe almost 100 thousandths each way. And so what I can do when I go to the bandsaw, I can cut down here, back up, then I can cut over here, and this creates room so that the blade is a 1/2 inch thick. I can turn the blade around and get positioned where I can cut this out. When we're finished getting that cut out, we'll come back to the mill and we'll show you some of the neat features that we designed for this. Okay, we got this bandsawed out now, and I made a small miscalculation. I got to take about 400 or 500 thousandths deeper on that, but I figured instead of trying bandsawing it, I'll just mill it out. One of the problems that you're going to experience when you put something in here, in a vise like so, and it's a thin plate, and if you put a lot of pressure, it's going to bow up on you. So what I'll do is I'll just stick it up there and just lightly touch it. And what I did is I drilled and tapped some 1/4-20 tapped holes in the front and the back. When I'm not using these holes, I can put these button head cap screws in there to keep all the little chips and stuff from filling up and having to blow that out all the time. It just keeps the threads nice and clean. You can take a couple parallels, set them down like that. I made some clamps that are adjustable depending on the height of your part. What you can do at that point, you can put the clamps in, and I have them preset already. What you want to have these clamps so that they're always at a slight angle this way. You don't want them at a slight angle that way. And the way I do is I'll just hold these down and I'll finger tighten these until it hits this parallel, and then I'll give them about 1/2 to a turn more. And then that will give them a slight angle that I need. So 5/16 thin mill in here. This plate is long enough. I may get some vibration in here. If that's the case, I'll see if I can put a gauge block under there and a clamp to hold it from there, but we'll see what it does. This is a method that I call chopping. It removes a lot of metal real fast. Generally, I like to use it with older end mills that are a little beat up. Wind at about 1/4 of the current of the screw each down pass. So it should be roughly 50 thousandths put it in. We just finished cutting the C section out right now, and what we'll do now, while I have this up here, I will grab the dimensions and then we'll drill the tapped holes in there. And when we get that done, we just have to deburr it, surface grind it, bolt it together, and this part will be done. Well, we have the new model of the hold down plate complete. I used brass hinges on this so I won't have to deal with rust. With this newer base right here, we kept this edge so that it would be about 1/8 inch less than the clamping edge. And having this extra meat on there should help out a lot as far as the holding power. Let's move over to the magnet and we'll check it out. You can see that we have a lot more strength in the hold down from the magnet on this piece because of the material that we added over here. And you can see this is locked in there nice and solid. We shouldn't have too much problem with that wanting to move on us when we put a diamond wheel and grind it. One of the things that you want to do when you mount both of these plates on this hinge is you want to just get the screws where they're just finger tight, and then you want to squeeze in and then tighten down. Their clearance holes are in the hinges. You want to squeeze that together so that if for some reason these screws would come loose, they're still pushing against the sides of the screws over there. If we didn't take the slot between the clearance holes and they'd come loose, and then this would come up far enough, it could actually move on you. But this is looks like it's going to be a very effective way to hold stuff on the surface grinder that's non-magnetic. We hope that you enjoyed this video. If you like it, subscribe, give us a like, and we'll see you next time.